Okay, last chapter, all about circles. Okay, so you've made it almost there, you guys. So today we're going to review some of the things we should already know about circles, at least some of the definitions that we have here. So a circle is the set of points in a plane that are equal distance from a given point called the center. A circle is named by the center. So if we put this as P, this would be known as circle P. That's how you notate it right here. Okay. The radius is a segment whose endpoints are the center and any point on the circle. So we went from the center to an endpoint. So this right here is the radius. From here to here. Okay, a chord is a segment, that means no arrows at the end, whose endpoints are on a circle. So that would be this right here is a chord. Because its two endpoints are here and here. It's on the circle. A diameter is a special chord that goes through the center. It always passes through the center. Okay. It's the longest chord in a circle, and the length of the diameter is twice the length of the radius. So that's this right here. That's the diameter. A secant, okay, is kind of like a chord, but instead of being a segment, it is a line. So it has arrows at the end that intersects a circle in 2 points. So that's this right here. The secant. And again, it has arrows. Tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. Okay, so it doesn't cross twice, it only crosses once. And that would be this right here. Any questions over that? We're good? Okay, coplanar circles. 2 circles can intersect in 2 points, 1 point, or no points. Coplanar means they're on the same plane. Okay, if you remember what a plane is like a flat sheet of paper that extends forever up, down, right, and left. The back wall would be a plane. The ceiling would be a plane. Any kind of flat surface. Okay. So let's draw 2 circles that intersect in 2 spots. Here's one circle. And another circle. So they intersect in two spots. 2 points of intersection. Okay, we're gonna draw two circles that intersect in just one spot. These are called tangent circles. So again, we're gonna draw a circle. And they intersect in exactly one spot. It can look like that, or it could look similar like this, where a circle is inside another circle. And intersects in just one spot. So either way. And then we can have, they don't intersect. They can have a common center or concentric circles. Concentric. So you just have two circles that don't intersect, like this one doesn't intersect with this one. Okay. They don't intersect. Or you can have concentric circles. This is harder for me to draw. Okay. So here's a circle. And you can have one inside it that is, oh, undo. Kind of sort of like that, where they share a common center. So they'll never intersect. Kind of like a target or a bullseye when you're playing darts. Any questions over that? Okay. Okay, in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint on the circle. Okay, so let's see what that would look like. Here I have a line. I'm going to label it line L. You can label lines with 2 letters, with a lowercase cursive letter. Okay. And then we'll label this circle A, and this is B. So we'd say if line L is perpendicular to segment AB, then line L is tangent to circle A. You guys remember what perpendicular means? Who said it? Right angle, okay? If you don't know that, you need to know that. Perpendicular. Equals 4 right angles. Okay, so when I try and prove something is perpendicular, I need to prove it's a right angle. That's how I can prove things are perpendicular. So in this one is line CE tangent to circle D. In order to prove that they're tangent, I need to prove that ED, segment ED is perpendicular to segment EC. Okay, because that's what that theorem I just said was. A line is tangent to an circle if and only if the radius is perpendicular to at the point of tangency. Okay. So in order to prove that those two lines are perpendicular, I then have to prove that I have a right angle, right? Prove that angle E is a right angle. Anyone have an idea on how I can prove that angle E is a right angle? Yeah? Yes, how do I going to prove that that angle is 90 degrees? It looks like it, but doesn't mean it is. Yeah? Pythagorean theorem. Okay? In order to do that, I need to prove triangle DEC is a right triangle. And to do that, I use the Pythagorean theorem. A squared plus B squared equals C squared. In this picture, what would be the hypotenuse? 45. So this would be C. Okay. Any questions over that? So I'm going to get 11 squared plus 43 squared should equal 45 squared. So that's 121 plus, what's 43 squared? 1,841? 49. And what was 45 squared? Okay, when I add these two, I should get 0, 7, 9, 1. Are those equal? No. So this is not a right triangle. Okay? So that just now shows that that is not tangent. Okay. So we'd say no. Not a right triangle. Okay, that then means that line CE is not tangent to circle D. Any questions over that? Okay, if they were equal, then that would prove that they are tangent to each other or tangent to the circle. Okay, on the back. Okay, in this diagram, it says that S is a point of tangency. Okay, when I have that point of tangency, that means I have a right angle. That ST, that means ST is perpendicular to SR. Okay, which then makes that a right triangle. And they want us to find the radius. So again, we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. So my A is right here. A is r squared, plus my B is the 48. My C, though, my C is this whole thing. It's the r plus 36 squared. Okay, don't just do 36. Because it doesn't make sense that 36 would be the hypotenuse, because that's not bigger than 48, right? So that wouldn't work out. It has to be the r plus the 36 here. Okay, so let's do that math. We're going to get r squared plus, what's 48 squared? (2,304). Okay, to multiply this out, you need to use your box. Remember, this is r plus 36. This is r plus 36. R times r is r squared. 36 times r is 36r. R times 36 is 36r. And 36 times 36? 1,296. Thank you. Okay, then we combine our like terms. So we'll still have r squared plus 2,304 is going to equal what's inside the box. R squared. Then 36 plus 36, because those are like terms. 36r plus 36r. Very good. Is 72 r's. Plus 1,296. Okay, I'm going to move my r squareds to the same side. So I'm going to subtract r squared here. If I do that here, it'll go away. Which makes this problem a lot easier because it's no longer quadratic. So I have r squared minus r squared is 0. So I'm left with 2,304. R squared minus r squared is 0. It equals 72r plus 1,296. Yes. Me too. Continue solving that for me. I'll trip over his bag. Okay, so you're going to subtract the 1,296. Okay, divide by 72, divide by 72, and what does r equal? 14. So the radius is 14. Any questions over that? We're all good? Okay. Okay, another theorem is tangent segments from a common external point are congruent. Okay. So I'm going to say here, if CA and BA are tangent to circle P, then CA, segment CA is congruent to segment BA. Any questions over that? We're all good? So in this problem, it says that AB and BC are tangent to circle D. Solve for X. Since they are tangent, that means that BA is congruent to BC. Segment BA is congruent to segment BC, according to that theorem we just talked about. So we can set this equal to each other. X squared minus 4 is going to equal 21. I'm going to add 4 to both sides. I'm going to get x squared equals 25. I'm going to square root both sides. And I'm going to get x equals 5 and negative 5. Now if I plug 5 into this, I'd get 21. If I plug negative 5 into this, that would still give me 21, so those both work. So I need both of those answers. Any questions over that? Okay, you guys try this one. Find x and explain. Okay, most of you were able to come up with x equals 15. Okay, your explanation would be that the radii are perpendicular to the segments therefore the segments are tangent and congruent. Okay, once you prove that these are tangent because they're perpendicular to the radii or the radius, then you can prove, then that means they're tangent, so they are congruent to each other. So using both those theorems we just covered. Any questions over that? Okay, I'm going to have you guys work on your 9.1 homework, and then we'll start working on our next set of notes.